Buzz duct accessories. Enclosure expansion joints. Introduction. Rubber bellows and metallic bellows are two types of enclosure expansion joints that are installed in a busbar system. Rubber expansion joints are provided in busbar systems at the interface of connected equipment, to cater to minor misalignment of flanges or housings of the connected equipment, isolate and attenuate vibrations when connected to a generator, compensate for foundation settlement, compensate at the expansion joint in a building, provide electrical isolation of the connected equipment to the busbar systems, as in the case of an isolated phase bus. Rubber or metallic expansion joints are provided in the run of the busbar system to compensate for linear expansion or contraction of the enclosure caused by the variation in its operating temperature due to load variation or ambient conditions. Rubber bellows. Expansion rubber bellows are made from several compositions of rubber compounds including butyl, EPDM, FKM, hypalon, neoprene, nitrile, silicone, and Viton. Neoprene and EPDM are the most common compositions of rubber used in the industry. EPDM and neoprene are both elastomers, long-chain polymers, that can be vulcanized, extruded, molded, and reinforced. EPDM and neoprene are expected to be impervious to dust and moisture. However, when used in bellows, they can be punctured with any sharp object. It can suffer such damages during installation. It is, therefore, recommended to reinforce the bellow with nets of cotton, nylon, or rayon to make it strong without losing desired flexibility. Ethylene propylene diene monomer, EPDM, rubber exhibits outstanding resistance to heat, ozone, steam, ultraviolet radiation, and the weather. It is also an electrical insulator. Neoprene exhibits superior performance when flame resistance, resistance to oil, gasoline, and other petroleum derivatives are required. A backing ring must be provided along the periphery of the rubber bellow while clamping or bolting. This will ensure that the bellows are uniformly pressed against the mating flange. Bellows can be suitably profiled at ends for better interface connection. The bellow assembly must provide the desired degree of protection specified for the busbar system. This could be challenging for outdoor installations. Sealant may be applied especially when installed outdoors. Earth continuity across the rubber bellows may be ensured by installing a flexible or laminated conductor of adequate size. Rubber bellows may need replacement during the life of the connection. When installed outdoors, the assembly is vulnerable to elements and corrosive atmospheres. When installed in the run of an isolated phase bus, a rubber bellow will need bolted aluminium laminates across it to carry the enclosure circulating current, which is almost equal to the rated conductor current. Further, it is necessary to have a bolted laminated conductor joint at the same location to facilitate the replacement of the bellow, when necessary. It makes the conductor and enclosure expansion joint quite expensive. When installed outdoors, the rubber bellows needs to be protected from elements by providing a canopy. Rubber bellows. A few mechanical, thermal, and dielectric properties of neoprene and EPDM rubber are detailed in Table 17.1. Percentage elongation of neoprene rubber is almost double that of EPDM rubber. This is a very desirable property for an expansion bellow. Metallic bellows. Installation of metallic aluminium bellows at expansion joints is preferred instead of rubber bellows in the run of an isolated phase bus. The metallic bellows are welded at either end between the adjacent enclosures of isolated phase bus. Metallic bellows are made of approximately 3 mm or 1/8 inch thick aluminium sheet, formed in a semicircular shape. Thickness can be built up by stacking these together. The thickness of the metallic bellows must be the same as that of the enclosure to ensure the same current carrying capacity for uniform temperature across the joint. If the thickness of the bellow is less than that of the enclosure, it is a practice to increase the effective cross-section of the expansion joint by providing aluminium bypass laminates, uniformly distributed along the periphery of the enclosure expansion joint. The profile and thickness of the expansion joint will depend upon the envisaged expansion or contraction and desired flexibility. The higher the thickness, the larger will be the diameter of the semicircular profile. Installing an aluminium expansion joint at site in the run of an isolated phase bus is challenging. The aluminium laminate on the conductor have to be site welded at least at one end of the conductor. The other end could be factory welded. The welding and subsequent inspection and testing of the conductor weld has to be carried out in the constrained gap between the two enclosures' ends. Aluminium enclosure expansion joint is subsequently welded across the gap between the two enclosures. Thank you. For a comprehensive understanding of the theory and practices of Busbar Systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.